Hi, Dr. Xiaohan. My name is Ganiwan and our team is made up of Jocelyn, Sean, and me. Today we are honored to present our project on the topic of AI technique to beat 2048 using expected algorithm to you. Why did we choose this topic? Well, we chose it as conceptually easy to play, but generally not easy for the player to win the game because the player usually do not think about the future possibility. I believe that in the next 20 minutes you will know more about how AI play this interesting game. As I mentioned earlier, 2048 is a single-player sliding block puzzle game created in March 2014 by an Italian web developer, Gabriele Cerulli. It is designed in a 4x4 grid board which has a total of 16 tiles. To play this game, the first thing we need to think about is to swipe the tiles up, down, right or left, and all tiles will swipe to a direction together on the board. When two tiles of the same number collide, they will merge into one tile such as 4 by 2 plus 2. And score will be accumulated by sliding and the player's highest score will be displayed next to the current score. The goal of the game is to get 2048 tiles, and player can choose to continue combining more to reach a higher number to get a higher score until all tiles on the board is stuck. Let's see how we made this project happen. First, we understand the fundamental of 2048, which is what is the goal of the game, how to play the game, and how to reach the goal, and so on. We also analyze the code of a 2048 game in Python and play the game and research on how we can use an AI to run the game. Other than that, we also understand the potential of AI of killing the game than human power and analyze which algorithm and heuristic function for our AI. Also, we test the AI to see the percentage of winning game. So, after 13 experiments with AI playing the game, this is the result we get. According to the chart, by calculation and experimental proof, we know that a score of more than 20,000 is equivalent to at least 2048 tails on the board and represent a win in the game. In this project, Expected equipped with 3 heuristic functions is able to produce nearly 80% winning of games on average. The result of the expected search algorithm is generally a success.
Good day to Professor Xiao Han. My name is Joycelyn Yeo Hui Lin, and I will explain the artificial intelligence concept we use for this program. Our 2048 machine uses Expectimax algorithm to inform its decisions. When it is the opponent's turn, it replaces a random blank tile with a number 2 tile. The functions of Expectimax are stored in the expectimax.py file, as shown here. It is part of the term 2048 folder. Our opponent acts randomly, so we use Expectimax to search through all the possible actions that the opponent may take, and then score each state based on certain heuristics. The next move function tries out every move, left, right, up or down, to generate the new state of the board when the move is made. They pass this state to the Expectimax to calculate the heuristic score. The Expectimax function then simulates the sequence of turns between the AI and the opponent. It considers all possible new tiles that emerge when opponent plays. We cannot prune our tree, so we have to explore each leaf. We have H-score, which is the heuristic score that we use to determine whether or not the state is the best state, and in turn helps us to determine whether or not this is the move that we should make. It tries first making all left moves and generates the score there. It obtains the score by calling Expectimax with one less turn and false, so it is passed to opponent. The mark is the points that we obtain by making that move. In the Expectimax function, we first check if we still have moves to be made. N is actually the depth of the tree that we traverse. If the board can no longer make any moves, it returns this leaf is very undesirable. We should not ever go down this path. So since earlier we saw that max player was passed as false, so it enters here, which is where the opponent will play. It places a number 2 in one of them. It places a number 2 in all of the possible empty cells and then allows the AI to see whether the move that it makes will generate a good score or not. So if we finally run out of moves to make, after we've traversed a certain depth, then it will return the heuristic score following the equation pattern heuristics minus cluster heuristics plus monotonic heuristics.
Good evening, Dr. Xiaohan. I'm Sean Lim Junjie, and I'll focus on the heuristics of our program. Heuristics are the methods that we use for our AI, which are pattern heuristics, cluster heuristics, and monotonic heuristics. After playing the game for several times, we observed that by placing the higher number tile in the corner, the possibility of a lower number tile merging will be higher. This is because the chances of a higher number tile to merge is difficult. So if it is placed in the middle, it will block out the chances of a lower number tile to merge with others. So as the name suggests, pattern heuristics will give us a pattern by multiplying the current state of the board with the weight matrices that we assign. For example, multiplying 128 with 30 plus multiplying 32 and 15, and it goes on. Then we divide it by 16 to obtain the average sum of the tile. So the higher the average sum, the better. By just using pattern heuristics is not enough. We observe that there are chances that a higher number tile may be placed in a different corner than the 30. For example, maybe you place at 15, at 5, at 3, at some occasions. So we introduce to you cluster heuristics, which will apply a penalty to the tile with higher neighbored tiles, because this will only affect when the neighbored tiles have a huge difference, but if it has a small difference, it will not affect much. We aim for a lower penalty to obtain a higher score. So we calculate the penalty by minusing the top 2 rows with the second and third row, and it goes on, as you can see, we plus this 4 together and we'll divide by 2 because we have an overlapped value to obtain the penalty, and this penalty will be minus out during the calculations of our heuristics. In addition to both heuristics, we also have monotonic heuristics. Monotonic heuristics ensures the tile to align either in increasing order here or decreasing order. The heuristics only place in 2 directions, which is this direction and this direction, so that it can decrease the complexity of the code. We calculate mono heuristics by obtaining score 1, which is dividing the lower half of the last column with the upper half of the last column. Same goes to score 2. Then we will take the sum, we times it by 20, so that the higher the score obtained, the bigger the difference after it's multiplied. The score only adds up if the result of the division is 2. So for example, here is 64 and here is 32, so the score will add up. By applying the 3 heuristics together, which is we're taking the pattern heuristics, we minus up the cluster heuristics and we plus the monotonic heuristics. Then we will get this result. As you can see, the program is following the heuristics. By pattern heuristics, the higher number tile is obtained in its place in the bottom right corner, and for monotonic heuristics, it is aligned in these 2 directions, and leaving the rest of the 9 tiles from the calculation.
Hi, my name is Jocelyn Yeo, and again, I'm here to explain how we implemented the code into our program so that it actually executes 2048 artificial intelligence. So before that, you are required to have Python 8.3.1 running on your desktop because the code was written in Python. You will also need to install -r requirements tags and NumPy. So after you've installed the file that our code is in, extract it, and then install these two things. So for the code flow, I will now demonstrate it using command prompt by running the program. First, you need to copy the directory where the file is located, and then we will load command prompt. So we change directory to this, and then we will type python run.py -expectimax. So now we have our running expectimax here. And when we type run.py, what we are actually doing is we are running this Python file, start game, from UI file in the term 2048 folder, terminal. So in this UI file, it will start game and return the score that we obtain once we run game. So in game, so game loop is where the game will actually run. It calls, the file is expectimax move, and it calls the function next move, passing the board as well as an n of 5. So n here represents the depth in which we will run the expectimax. And then it returns the score as we had discussed earlier in the expectimax algorithm section. So now we will see this expectimax move file. There is the next move function as well as the expectimax function. And we also import heuristics to calculate the score in which we evaluate which state is the best one. So the score that we get is a sum of the heuristic score after this move has been made. So once it goes through 5 levels, then it will return this heuristic score. So this heuristic score added with the points that we earned from the move. So it will make a copy of the current state of the board and then make that move. So we'll see later what move function does. It's from the board file. So it will check whether the newly generated state is any different from the initial state that we had copied earlier. And it will simply return, after all this is run for every possible direction, left, right, up or down, it will return the final move. The final move being the one that has the highest score. So now we will see what move does in the board file. So the move function, we will copy the current line and then it will run move line. So move line according to the direction that we input here. Like for example, if we were to go left. So if we moved left on the line that we have, any of the cells that are next to each other and have the same value, such as 4, 4, 2, 5, 1, 2. So 4 and 4, if you move left, then they will combine to become 8. So the new line generated will be 8, 0, 2, 5, 1, 2. So once you've merged the two tiles that have the same value, an empty tile will be inserted in the opposite side. So since it moved left, the empty tile will be placed on the right side. After we've run this one, then we will merge the adjacent tiles. So in collapse line or column, since we moved left earlier, then it will check if there are any empty tiles in that line. Since it was 8, 0, 2, 5, 1, 2, and the 0 that was in the second tile earlier will be shifted to the back. So then it's as if the 2 and 5, 1, 2 were shifted left. So it will become 4, 2, 5, 1, 2, 0. And you return this newly collapsed line. So we will move again. Like earlier we said we will move the line. And then we will set this new line back into the board by replacing the original one. Because we carried out this operation, this move, collapse, and move on the copy that we made. So this copy will replace the new one. And then finally, it will check whether any of these operations that we did actually generated a new state. And if it did, then it is considered to have been moved. And it checks again. So if it fulfills the condition that there was a move and there was an add tile, because add tile here is already considered true, then we will add a new tile. See, it adds a random tile in an empty cell. So in any of the empty cells, it will randomly insert a new 2 or 4 tile. So in the heuristics file, we have the pattern heuristics, cluster heuristics, and monotonic heuristics. So as you can see here, after we finish running the code, our AI successfully beat our opponent and also even generated a new high score. So that is the end of our presentation. Thank you very much, Dr. Selhan, for your attention. We hope that you enjoyed our presentation.